Photovoltaic panels are PV cells that generate electricity from the sun, come in all shapes and sizes. You can even get them to where the PV cells are integrated into roofing shingles. With me is Bill Brooks, who's an expert on how to install these systems. What is the first step?
Well, first of all, you need to find a qualified installer, somebody who knows what they're doing, who's been through the process with references, things like that. And then once you find somebody you're comfortable with, they're going to walk you through a process in which they're going to find a site for the solar panels. What they're going to use is they're going to use a device like this. This is a solar pathfinder. This is what we use to perform a shading analysis on the house. Okay, this is how we determine whether or not a tree or a neighboring building might be causing a shadow on the solar array, producing lower energy on the course of the year. And so if we look at this, we'll actually trace, and you see here a line that's traced on this piece of paper, and that corresponds to a building that would actually shade this, this particular point. And everything on this side of that shade line is lost energy. And basically this is saying that there's going to be a lot of lost energy here. And so we might want to look for another location to put the system. And so this way we can then determine what is the best location for the system so it produces the most energy for the homeowner. Maybe it's a roof, or maybe it could be a trellis work in your backyard, some location that's as free of shade as possible and is facing as close to south as possible. Generally the sun stays in the southern sky most of the year, and so throughout the spring and fall and the summer that's when we get our most sun, and we want to be facing toward the south. We could even be facing a little bit toward the east and west. In fact, a west facing or east facing roof, as long as it's a fairly low tilt, will produce maybe 85% of what a perfectly faced south tilt might do.
Now, shade has a big impact on how these work, right?
It has a huge impact. These types of devices that help us find the least shady spot are so important, because once we have that, the rest of it is a fairly straightforward process.
What about mounting the panels?
If we're going to mount on the roof, then it's very critical that the roof mounting be weather sealed. These systems are designed to last 25 years, so you want to be mounting with systems that are going to last that same time.
What about the weight of the panels? Are they heavy?
Not too heavy. They're equivalent to about another layer of roof shingles.
What happens next?
You bring the panels up onto the roof and you install them into groups and wire them together. Then typically you have some kind of conduit that takes the electrical wiring, runs it down the side of the house to an inverter where it takes the power and turns it into from DC power into AC power.
Is the inverter inside or outside?
Often they're in a garage area, or it could be outdoors.
How close to the meter do they have to be?
Well, the inverter could be a long ways from the meter. That's not really that important. However, there are disconnects that are required by the code that must be near the meter for utility personnel to be able to form a disconnect with the system.
So, Bill, how do you test these systems out?
And first thing we're going to do is actually test the individual modules even before we take them up on the roof. So if we find any problems right there, we can deal with that right then. Then once we get them up we put them in panels in series, once we get that series string together, then we have some type of a combiner that takes the individual strings and brings them all together in one large group. At that point is where we do our testing of individual strings, and we'll see whether they're putting out the proper voltage and they're doing their job. Once we get that figured out, then we turn our attention to the AC side, make sure all our AC wiring is correct up to the inverter. So we've got our DC side correct, our AC side correct. Then we can go through the procedure to start the inverter. So the inverter is a sine wave synthesizer, and it synthesizes the DC power into a waveform that is compatible with the utility company, and actually runs directly in parallel with the utility. Okay, that whole process needs to be just right. And so what we'll do is go ahead and we'll power up the AC side and we'll power up the DC side, allow the unit to start to run, and then we'll test the individual strings under load. When we test them under load, then we learn a lot more about whether all the system is doing exactly what it's supposed to do.
What about performance? How do we make sure that these are performing properly?
Good question. Basically, the contractor needs to be able to know, based on how large their system is and the conditions that it's under, how much sunlight there is, what the system should put out at virtually any time. And there's a procedure that actually California Energy Commission has on their website in their installation guide that runs the contractor through those steps, and you can actually very accurately determine how much sunlight you have, and then alternatively how much AC power the unit should be generating at any given time.
What are the most common applications for PV systems?
Well, there's certainly used in commercial and residential all over the state of California. And so in residential, they're put on rooftops and on shade structures, on all kinds of different places that they can be used for shading. They actually can keep the house cooler if they're up on the roof. These systems are used directly in connection with the utility system. Some of those systems actually have battery backup power, so they provide power in case of a utility outage. So there's the residential applications. On the commercial side, most of those applications are either on flat roofs, where we can take advantage of the huge expanses of low-rise construction that we have in the commercial industry. So that's one application. Also parking areas. Parking areas are a great place. People say, well, where do you find the acreage to put all these solar panels? Well, we have acres and acres of parking lots. We have acres and acres of flat roofs available to us that are wonderful places to put solar panels that are really not good for much else. If I had my car out in a parking lot somewhere on a sunny day, I'd love to have something to cover it and keep it cooler. So these things provide a benefit to the people that park in those areas as well.
So Bill, when do these systems make economic sense?
Well, certainly there's the energy that they generate, and so that's going to offset the electricity usage of the customer. And so that's certainly the first and foremost reason to install one of these systems. It's an electrical generator, right? But then there's also other reasons. Probably the two other most common reasons is that it doesn't burn any fossil fuels, so it helps air quality. People like it because it's going to help their grandkids, things like that. And the other reason is that it helps them achieve some level of independence, so that they don't have to worry about what happens to the future costs of electricity.
Great information.
Thanks
for being here. Photovoltaic panels are becoming more and more popular. Some cities, in fact, have voluntary and even mandatory requirements for photovoltaic systems. If you'd like to learn more about these systems and some great incentives, check out the other videos on this website.